Morning, this is your Stats Sensei, Mr. Spensei, and this is the exit ticket focused on the inverse normal. That's what it's primarily focused on. All right. And whenever you're using an inverse normal, you'll know that because they will give you an area, a percent of probability, and they will tell you it's normal. So the time taken to produce a batch of products in a factory follows a normal distribution. Yay, they told me it's normal. A batch of products is in the fastest 1% of production times. What is associated with Z score? So they're not asking us about the actual value. They want the Z score. And remember, for all Z scores, the mean is 0 and the standard deviation is 1. Also note, if they give you a percent, anytime they give you a percent, that lets me know I'm working with an inverse norm. They gave me a percent, so it's inverse norm. But I also recommend putting an X and go, is that 1% above X or 1% below X? Well, this is the fastest. So the fastest should be above it. And remember, we always put percents over 100. So my graph is going to look something like this. All right, we have a mean of 0 because it's a Z score. We have a standard deviation of 1. And we're looking for the upper 1%. So this is going to be 0.01. And I'm looking for that particular Z score that's associated with this. So inverse norm, the very first thing the calculator is going to ask us for is the area. Well, in this case, our area is 0.01. Our mean is 0. And our standard deviation is 1. That's true for all Z scores. So this is our percent, our mean, our standard deviation, our PMS. Second vars, inverse norm. So we're going to have 0.01, mean of 0, standard deviation of 1. And if I notice, I'm shading from the right. From the right, make sure that's highlighted. And I end up getting 2.3263. All right, box our answers. That's our Z-score. We're done. A batch is the slowest 25% of production times. What's the associated Z-score? Once again, they gave me a percent, so lets me know that I'm working with an inverse norm. And remember, we always put in X, and this is the slowest 25%. Well, slow is going to be on the low side, so 25 over 100. 0, and this will be on the low side, and this will be 0.25. And we're looking for that Z-score. So inverse norm, the first thing it's going to ask for is our area, which is 0.25. All Z-scores have a mean of 0 and a standard deviation of 1. So there's our PMS. So second vars, inverse norm, area, 0.25, mean of 0, standard deviation of 1. But we are shaded from the left, so we need to make sure left is highlighted on a calculator. And we get negative 0.6744. You're like, gosh, does a negative number make sense? And the answer is yes, it does. And here's why it does make sense. Our Z-score is less than 0, so this should be a negative number. This was a positive number because our Z-score was greater than 0. What Z-scores are associated with the middle 67%? So once again, they gave me a percent. If they give me a percent, I'm looking at an inverse norm. My area is 0.67. All Z-scores have a 0 and 1. And in this case, when I draw my picture, be careful about this. We're centered at 0, but we're centered at 0. There's our mean, and we're supposed to have in this area 67%, but I notice I have two bars. So I'm going to have a Z here and a Z here representing my lower and my upper bounds. So I'm going to have some number less than 0 and some number greater than 0. So second vars, inverse norm, area 0.67, mean of 0, standard deviation. And now we're going to choose center because that's what we highlighted. We highlighted the center part of the graph. And we get negative 0.97411 and 0.97411. And it's symmetric because the normal curve is symmetric and we're centered on 0. If we're centered on some other value besides 0, it won't be symmetric. All right. There's our values. Z-scores don't have any units, so we don't have to write them down. All right. The height of a certain species of tree in a forest follows a normal distribution with a mean of 30 and a standard deviation of 3. So they're telling us mu equals 30, standard deviation is 3. What percentage of trees will grow to at least 35 feet? Well, they're asking me to find the area. If they ask me to find the area, it's going to be a normal CDF. Let's draw our picture. And we have a mean of 30. And they want the probability at least 35. That means it has to be bigger than 35. So we're looking for the probability that X is greater than 35. So I'm going to put a 35 here, and I'm looking for this area. Please remember, this goes to positive infinity. So norm CDF, when I go to norm CDF, the calculator asks for my lowest part first. It asks for the lower, the upper, the mean, and standard deviation. Well, the lower part of my shading is 35. We're going to positive infinity. Our mean is 30, and our standard deviation is 3. So in this case, this is my lower, upper, mean, standard deviation, or LUMO. All right. So let's plug those into the calculator. 35, upper 9 raised to the 99th. That's the largest number it'll take. Mean of 30, that's the actual mean, standard deviation of 3. We only use the 0 and 1 if we're looking for z-scores. Here we're looking for actual values. Press enter. And we end up getting 0.04779. All right. So that's our probability. We could have changed it back into a percent, but we'll just leave it just like that. That's fine. The next thing, it says 10%. Oh, so they gave me a 10. If they give me a percent, they gave me a percent, that tells me I'm doing inverse norm. And when I draw my picture, we know we're centered on 30, but before I get too far, anytime I give you a percent, put an X. Grow shorter. Oh, well, shorter is a small number, so that means it has to be down here. Remember, we always divide by 100. So this right here is 0.10 because that's 10 divided by 100. And we're looking for this X value. So when we go to the calculator on inverse norm, it's going to ask for the area, which is 0.10. It's going to ask for their mean, which was 30. And they asked for the standard deviation, which was 3. So 0.10, mean of 30, standard deviation of 3. There's our probability or our percent, our mean, our standard deviation. That's our PMS. And we're shading from the left. And we end up getting 26.1553. 26.1553. And we're measuring in feet. There we go. 80% of the trees will grow taller than how many feet? Well, in this case, I put my X. Taller is on the upper side, so this is up here at 80. 80 over 100. My picture is going to look something like this, centered at 30. Well, 80 over 100, that's 0.80. This is 50%. So I'm starting here and I'm going this way. There's 50%. So I got to cross that. And I need this area right here to be 0.80. And I'm looking for this X value. Because they gave me a percent, anytime they give me a percent, it's going to be inverse norm. And my area is 0.80. My mean is 30. My standard deviation is 3. So there's my PMS. Second vars, inverse norm, area 0.80, mean of 30, standard deviation is 3. Now notice we shaded from the right. Always check to see which way you're shading from. That's why that picture is so important. And we end up with 27.4751. Feet. All right. 91% of the trees fall within what interval centered about the mean? All right. So they tell me there's a percent. So I know it's going to be an inverse norm. I know this is going to be 0.91. I know my mean is 30 and my standard deviation is 3. There's my PMS. But we need to draw a picture of this. Now, this picture, we're centered. When we're centered, this is 0.91, mean of 30. And I'm looking for an X here and an X there because I want this part right here. So this is my lower bound and my upper bound. All right, so here we go. Second vars, inverse norm, our percentage 0.91, mean of 30, standard deviation of 3, and we are centered. That's what we drew here. And I get two values. There's my lower bound and there's my upper bound. So 24.9138. 24.9138 and 35.0861. This is in feet. Box that. And there we go. Sure hopes that helps. And I look forward to seeing you on the next one. Thanks for watching.